Good afternoon, everyone. My name is Deepak Misra. I am the mathematics faculty. Now, in this video, I'm going to demonstrate the topic that is continuity and differentiability. So, in this topic, we will discuss three important things. First one is continuity of a function. Okay. Second one is differentiability of a function. After that, we have some important formulas and we will take some important questions. Okay, so that it become easy for us to connect with them. Okay, now starting with the first term, that is continuity of a function. Okay, so before starting continuity of a function, we have to understand the word that is continuity. I think we all know what is continuity. If something is continuous, then we can say that it is in the form of continuity. Now, suppose we have a graph, okay, like this. Here is x-axis and here is y-axis. Okay, now if I just make a curve like this, starting from the origin and from this to this to this, and it never ends. Now, if you observe the pattern, without lifting my pen, I just make that curve. Okay, without lifting my pen, I can draw a curve. Then we can say that this curve is in the form of continuous. Then we can say that this is a continuous curve. Okay, now similarly, if I just make another curve like this, here I'm just break my point and another curve I make from this. So if you observe the pattern in this graph, starting from the origin, I make a curve like this. Here I stops, and from that stops point, I make curve again. Now here is a breaking point while making a curve. Then we can say that this curve is in the form of discontinuous. This is discontinuous and this is continuous curve. Okay, now continuity of a function. Okay, continuity of a function. Suppose we have a function like fx. Suppose we have a function like fx. If the value of a function and the limit of a function at point x are equal, then we can say that the function are continuous. Okay, don't be worried. I'm just going to take the example so that it become easy for us to connect. Okay, just wait. So suppose we have a function like fx equal to 3x plus 4 and we have to find that function continuity at point x equal to 5. Okay, now so here the given function is what? Given function fx is equal to what? That is 3x plus 4. 3x plus 4. So if we find the value of a function, that is f5, so f5 will become what? That is 3 multiplied by 5. 3x is what? 3 multiplied by 5. So 3 multiplied by 5 plus 4. Okay, so we got that is 19. So f5 is equal to what? That is 19. Now we find the limit of that function also. Okay, so limit x tends to 5 fx. Okay, so here fx is what? That is 3x plus 4. So 3 multiplied by 5 plus 4. Here it is already given that x tends to 5. It means what? Limit x, that is x approaches to 5. Okay, so here we got limit x tends to 5 fx equal to again that is 19. Now observe the question. We have value of f5 and the limit x tends to 5 fx, both are equal, that is 19. Thus we conclude that if the function value of a function and the limit of a function at that point are equal, then we can say that the function is continuous. Fx is continuous. I think it is clear. Okay, now second thing is differentiability of a function. Differentiability of a function is what? If the function is continuous, then we can say that the function is differentiable. Okay, now differentiability of a function is nothing, it's a derivative of a function. Now the question arises in our mind, sir, what is derivative? Derivative is nothing, it's a slope of a tangent, that is dy by dx. Okay, now so if we find the differentiability of a function, then we are going to find the derivative of a function. Okay, so here one important formula related to the differentiability of a function, that is dy dx of fx, or we can say that f dash x is equal to limit x tends to h f x plus h minus fx upon h. This is the important formula which we are going to use in the questions also. So whenever we find the derivative of a function, okay, that is dy dx of fx. Okay, fx is what, that is y is equal to fx. We generally take the uh, questions in the previous classes also. Okay, so dy dx of fx is equal to what, that is f dash x, and f dash x equal to, we have a formula limit x tends to h. Okay, x tends to h means what, x approaches to h. X is not equal to h. Okay, it just approaches to h. Okay, so we have limit x tends to h, fx plus h minus fx upon h. Okay, now let's discuss some important formula related to the continuity of a function and the derivative of the function. So the basic formula related to the continuity of function, as we have already also read in our class 11th previous classes, that is limit x tend to a, x to the power n minus a to the power n upon x minus a, that is n a to the power n minus 1. Okay, so here we have one formula, limit x tends to a, x to the power n minus a to the power n upon x minus a is equal to na to the power n minus 1. Another formula we have, limit x tends to 0 sine x by x is equal to what, that is 1. Okay, similar to this we have another formula, limit x tends to 0 tan x by x is equal to what, that is 1. These are some important formula related to the continuity. Okay, so now important formula related to the differentiability, the basic and the most important formula related to the dy dx. Suppose we have a function like fx, okay, and we have to find its differentiation, then what we are using, dy dx of fx, that is f dash x. Okay, now the first formula related to the differentiability is, suppose we have to find the dy dx of x to the power n. Okay, x to the power n is a function, so the formula will become what, n x to the power n minus 1. Okay, now suppose we have to find the differentiability of a function, that is dy dx of c x to the power n. So c here is what, that is constant, and constant will remain constant, so we just write c n x to the power n minus 1. Okay, similarly we have to find the dy dx of what, constant function, any numbers. Okay, constant function, so dy dx of constant function is what, that is always remember 0. Similarly we can also find the dy dx or f dash x of any trigonometric functions also, like dy dx of sin x, that is what, that is cos x. Okay, now suppose if I am going to take some example related to find the differentiability of a function, that is, let's take some example, 3x to the power 2. Okay, we have to find the differentiability of a function, like function is given fx equal to 3x square. Okay, and we have to find that f dash x, that is dy dx. So here dy dx of fx, so dy dx of fx is what, that is fx here is 3x square, so dy dx is of 3x square. Now here constant will remain constant. Okay, 3 is 3. Now x square, here if you just relate with this formula, dy dx of x to the power n is what, nx to the power n minus 1. The power comes first, so here 2 comes first, and x to the power 2 minus 1. Okay, so the answer will become 3 multiplied by 2, that is 6, and x to the power 2 minus 1 is what, that is 1, so we got 6 to the power x. Okay, I think it is clear. Okay, now Let's take some more examples so that it become easy for us to connect with that. uh, let's we have to find the differentiability of a function like fx is equal to x to the power 5. So here dy dx of fx is equal to what? Dy dx of x to the power 5. So dy dx of x to the power 5 will become what? 5 comes first. Okay, x to the power 5 minus 1. So we got 5x to the power 4. Okay, clear to you all? Okay. So with this, I'm just going to end my session. Okay. So thank you for watching the video.